Alright, so this video, I'm focusing on some debris fields passing by. Somebody sent me this the same day, the live meteor watch. I mean, you can see it just exploded with some activity. So I want to throw in this, scientific data that most people can accept, and then correlate that with what what I captured. But as you can see from the chart from yesterday, there's definitely some meteor activity up there, and it spiked for a good while. And kept on going, and this is in fast forward, of course. Just because it was spiking for so long, it would have made way too long of an intro. But you get the point. A lot of activity yesterday. Just kept on going. Now I don't even know how to read these these charts exactly, but I can tell that there was a lot of action going on. So without further ado, here we go. Alright, so this was yesterday. It's another one of those debris fields kind of brushing past. They have a very unique look to them. I'll show you plenty more examples in this video, but this is just the most recent one. When it even looks like something is causing that other than wind. What it really is these debris fields up above that, and the kind of smaller particulates. I mean, they're almost too small to even see zoomed in. Very small, or at least from the ground's perspective, but they are definitely up there causing that turbulence, just like the video that I'm about to show of Otto's moon and the OCGs that orbit under it. Those are pretty much one of my best captures, the undeniable something flying through that you can't just say is a cloud, and there's no plane, so there's no real good explained away excuses for that one. That's why I like to use it. This one right here. So Otto's moon's basically taking up most of that background up there, even though it's kind of out of sight, you can't see it. But these are the OCGs, the object cluster group that kind of orbits around them, just like this. On the bottom right, you actually have Otto's moon with its ion bleed off under. This is a directly straight up shot of them, just to give you examples that it is real. I mean, it just has a completely different look. It almost looks like they come into the atmosphere, just barely brush the top, and then almost like they're steaming or fogging. Like if they're really cold and they're coming down in a warm climate, basically you're gonna have like ice cubes, the fog that kind of bleeds off of them. It's the same kind of look. Here's a zoomed up view. You can see them there. It's like different densities. They're behind that, and they're kind of pushing it up as they brush against it. It's very, very hard to explain, hard to comprehend at first, but you can see how they kind of have that swooping motion that kind of came in, caused the disturbance, and then they fade back, and they kind of just go back out of sight. But depending on how close they are, what angle they come in, you're going to get different looks. Well, here's a closer up shot of the one from yesterday on my nicer camera. mean, you can't really have sharp angles and freaking right angle flat lines in the clouds unless there's something up there causing that. If you look at the kind of debris that looks like it's back behind that ion bleed off, they'll have straight, sharp points. But I mean, you can see that thing up there to the right. Those just aren't normal clouds. You can see that kind of little vortex, something rolling over, same as this capture that I caught back at the first of the year. Just a random freaking vortex puddle in the cloud. You know, it's these little objects. They're like, they look like little seeds or rice pods in the sky. They're almost transparent, but it's just because, you know, you're looking up towards the sun and the blue sky, and everything's drowned out by that bright light and the blue, and then you're basically seeing their dark sides with maybe slight illumination on the crescents. I mean, it looks like objects up in there that have, you know, that are steaming or fogging coming off of them. It's not like clouds. It's like, it's just, I don't know, just look at it and let your brain tell you what you think it is. This is back in March of this year. This is another debris field. I mean, you can see how they have a very unique look to them. I mean, it looks like there's chunks of something up there, you know, breaking the damn cloud. Some of the captures will actually be rolling, tumbling in the wakes. But for the most part, it just looks like chunky debris floating around, you know, in this ion bleed off. It's a smooth, silky kind of rolling motion to it as they kind of roll through the atmosphere. Of course, when they go next to the sun, you always get that kind of rainbow refraction going off all the dust particles. There's another one from that day. It just looks like chunky rocks, basically. I mean, it looks exactly like you would imagine a small debris field looking like, you know, floating through. I mean, you got to kind of imagine it as water. It's kind of the way that everything rolls, and you got the wakes. It's just a thicker density atmosphere pushing into a thinner one, or vice versa, a thinner one pushing into a thicker one. The different layers of the atmosphere have different densities. I mean, you get wakes like this, when you see wakes, dark wakes like this that kind of roll, and they have a very silky look to them, and they kind of roll. That's basically the lower atmosphere wakes from the big object that's moving above it. You got all these little random swirly break-off wakes that kind of spawn off in the lower atmospheres. Here again, some asteroids moving above the cloud level, causing that dragging wake. And here's another example of asteroids in the clouds, basically tumbling and rolling. You can even see that illuminated spot as it's rolling and tumbling the freaking cloud. And explain that away with normal physics. Doesn't work unless there's something up in there doing it. You can see the compressions, the lines, you know, the way there's little illuminated sphere bulges basically in there. It's the illumination from an object passing through there. I mean, they have an effect. They have kind of a magnetic effect, gravitational effect, whatever you want to call it. But they distort our atmosphere slightly around them to create those perfect sphere impressions. I mean, but they have a very unique look. And the debris fields come by every now and then. You know, if you're like me and you record the sky all the time, you'll eventually get them. but it just looks like some kind of chunky debris floating through, and it's kind of got a little. I mean, you can even see them right there in the base of that one. You know, just because you can't really see their color or anything like that doesn't mean they're not in there. They're just not. You're seeing their dark sides. They usually come from the sun's direction. They'll come in like that, kind of come down towards Earth, and then kind of just turn towards the surface and swoop off about cloud level and just fade back into the blue. But I mean, it reminds me exactly of, if you could imagine, steamy rocks, you know, or ice cold rocks passing through the atmosphere in our warmer density atmosphere, basically interacting and just kind of creating this ion bleed off fog type cloud that just kind of stays above them. You see their little sharp edges poking out from under it. The security cameras definitely capture them the best, or show them the best. For some reason, higher quality cameras you just get that blue bleed out. All you see is blue and white. But with my security cameras, for some reason they pick up the coloration a lot better, like the sandy orangish reddish look, dust. Because when you really get down to what these clouds, you know, look like without all the blue sky, you know, bleed off, they're darker. They have color to them. They're like a dusty or a red, or, you know, they're not all white. That's just the way everything looks when it passes through our sky with the sun and the, you know, the nitrogen oxygen interactions. I mean, that's a pretty damn good example of freaking little chunky debris inside there. Yeah, it's about every three or so months you get one of these debris fields passing over me. You know, you get those ripple wakes, and you know, the chunky breakup of the clouds, and you know, I mean, that's a pretty good one right there. You see that plane? It's freaking tiny. Those things are way up there. There's that rainbow look. The little ripple wakes everywhere. Those are all caused by individual asteroids up above that cloud level. You know, with the planets up above them. The farther up you go, the bigger the debris gets, all the way up to the planets. Which the planets are, you know, they're not right there. They're not in the atmosphere. They're way the fuck up. You know, they're just so big that they literally fill up the sky. You know, Earth's a pretty small rock compared to some of these gas giants and other planets. So don't let your perspective from here on the ground kind of fool your brain. You basically see these spheres are in there. You can't see them unless kind of cloud builds up around the edges of them and basically defines them for you. So I always say, look for the wakes, look for the trails. You know, like you're reading the surface of water and you're trying to find a freaking bug or a fish swimming under it. You're looking for those ripples, and you know, that's going to lead you to the actual objects that are usually up above. I mean, there's just no other explanation for this type of cloud right there, with these obvious something breaking through, the sharp edges and the clean edges, and You see all the damn wakes with the freaking chunky asteroids tumbling around in them, and then you got all these straight kind of ion bleed-off trails, individual ones, you know, leading off from each fucking group, each one sometimes. You know, the swooping little tails coming straight up, the horizontal wakes. There's usually a larger asteroid that's all the way at the front of this, you know, where that little bright cloud is at the very bottom of the horizon. There's usually a bigger one that's up there, and then this is all the debris that's basically being dragged behind it in its wakes, you know, getting tumbled as they go. But there's always a larger lead, you know, that's leading them on. And they're always at the front of the formations. When you see a V or, you know, a check type cloud, it's got a point. You know, that's because there's something at that point causing it. Alright, if you've watched my videos, you've seen enough examples of it. I literally have so much of this stuff that it's hard just finding it and putting it into a video. There's no more lack of content. I have plenty. It's just lack of time putting that content in an organized fashion into a video.